Hello everyone. So Debabrata once again. Today I will be starting with function because after for loops, array and matrix we have already learned. So after all these, function will be the easier topic now. Okay, so it is just a copy paste thing. So some people might thinking like, okay, function is just a copy paste thing. Is it really a copy paste, or we need to find some logic, or we need to write some logic on that? So I'll be saying just watch the examples I will be showing today, and it is just a copy pasting. So if you can write the logic by your own, functions will be just a copy pasting. Okay, so I will be showing few examples. What exactly then use of function? Why should we learn function? Is it just because of it is there in syllabus, or there is some reason why we should learn function? So that I'll be explaining today. So today, obviously, we will cover function in Java. Prerequisites are the programs we have already done in our from our playlist. We can go through all the classes whatever we have done, especially for application class will be important. So if you do not if it is your first class, I will request you to go to for application class. For application means 3.3 class. Okay, so for, and obviously you have to revise all those programs by yourself. You need to practice all those programs. You need to write all those programs by yourself, then only it will be okay. So the topic one is, as usual, as I have said, function is just a copy paste thing. So first I will start with this program. Enter three numbers and find their factorials. Let me go to any of the softwares first. We can go to Blue Java. If you want, you can go to any other compiler. So let me start with Blue Java itself. So if I create a new class like function demo, say a new class called function demo, and if I start writing a program there, class suppose function demo, and it is okay. Let me write all the necessary syntax first. Public static void main string args. In case of any doubt you are facing, just let me know in the comment section. I will try to help you out. So okay. Okay, what was the program? I forgot. Enter three numbers and find their factorials. Okay, fine enough. So first we need to put scanner class here. All right, and now, okay, scanner. Let's see. And now I need to take three inputs, obviously. I can write enter first number, something like that. And I can write int x equals to sc.nextInt. Similarly, I can enter three different numbers. Let me do that. The second number and the third number. And the second number will be suppose y. And I can simply take that inside second number. And I can print enter third number as well. And I can take the input inside z. So x, y, z, three variables I have taken input. And now I need to find the factorials. So first, I can write something int f equals to 1, f for factorial say. And after that, I can write for int I equals to 1, I less than equals to x. Suppose I am trying to find the factorial of the first number. Okay, so I equals to I plus 1 and f equals to f into I. So if you can remember our class, that is, as I was mentioning, it is 3.3 for application. You can get it in this playlist as itself. So we have already done this kind of program there. We have already done how to calculate factorial. We have done how to calculate prime. So all those programs will be needed here. Okay, so it is no new logic. We are just revising the factorial value, factorial applications. So we have just calculated the factorial, and now I am printing like the factorial of the value is x is, the answer is f. That's So it is the way how we can calculate the factorial for the first number. We can replicate the same thing for the second number itself. Let me show you. So suppose it is G, say, and we can do the same for 1 to I. Okay, it is for the first number. You can see the same thing we are doing for the second number. So we just need to write G equals to G into I. And here I can write the factorial of Y is G. The same thing. Okay, I hope you are able to understand. So for the third number, I will be doing the same, obviously. Int, suppose if gh, suppose let it be h. You can take any variable, so that is not something, that will not be something big issue. So you can take anything. So here I can write the factorial of z is h. So if I compile, yep, it is compiled. So let me execute that first. So if I execute, so obviously it will take three numbers as input. Okay, enter first number, it is saying, suppose I am giving 5, enter second number, I am giving 7, and enter third number, suppose I am giving 4. So the factorial of 5 is 120, 7 is 5040, I do not know. Factorial of 4 is 24. So, yep. So that program we already know how to do, how to solve. It is using the for loop itself. But function is saying if you are doing some repetitive work, do not do that. Copy it somewhere and reuse the code. There is no need of redoing things. Okay, so the main use of functions is reuse and reusability and modularity. You need to imply those two advantages by using function. So what is reusing? Let me show you first. So here we are writing the same type of code thrice, because in the question it is asking for getting the factorial for three different numbers. So instead of typing the same code again and again, we can do one thing. We can create a function for factorial. Suppose we can write something like public is, it is the first time we are going beyond of our main function. All of the functions, all of the programs we have written so far, it is inside this bracket. It is inside public static void main. So if we can create something similar like this, like let me give some name like public static void, any name. You can give my name Guha, you can give any name. So for the time being, let me give the name as let it be Guha. Okay, and let me delete this one. So it is a parallel globe. Whatever we have written till now, all the programs inside this public static void main, so let it consider as our earth, our globe. And a similar thing I have created today is like public static void Guha. It is a similar thing. And what is the meaning of public static void? We will know that in the upcoming classes. But for the time being, we do not need to know what does it mean by public static void. So I will tell that later. But I will first today we have created a similar function or a similar globe like our main function. So it is public static void, but the name I have put, you can put any name. For the time being, I put my name, it is Guha. Okay, so now what I need to do, I just need to copy this code. As I was saying, it is a copy paste thing. So let it be cut paste. Okay, so let me cut this code and let me paste here. Okay, I have done nothing else. So what I can do, I can delete all the repetitive codes. The codes are same thing, same codes I have written. I have just replicated the same code. So here, what will happen now? Program always starts from public static void main. A program always starts from public static void main. You can have similar functions in your function, similar functions in your program, like public static void Guha. You can have public static void something else like public static void Debabrata. Anything you can have, but program will always start from public static void main. So here it will start from scanner SC. It will take 3 inputs and program will be ended, because there is no direction to go to this Guha function. So what you need to do? After taking 3 inputs, you need to send X, Y, and Z to this planet. Okay, I am considering it as a different planet. So, and this is our planet. Suppose it is Earth, it is our globe, and it is a different planet. So we need to send X, Y, Z. They are suppose consider them as a astronaut. So we need to send X into this planet. Otherwise, the program will not execute these lines. So I am sending X into Guha, that planet. After that, I am sending Y into that planet. And after that, I will send Z into that planet. And here it will be, I will receive that as X, and the same code will be executed. So I am sending X here, and it will be landed here as X, and I will be following the same code here. It is easier. This chapter is very easy because you do not need to play with the logic. You do not need to think about the logic. You just need to think about how you can send an astronaut, or how you can send a variable to another planet or another function, and how the same logic will be executed there, and it will print the answer. You do not need to think about the logic. It will be the same logic. You just need to place the same logic here. You just need to send a variable, and you need to receive here. Okay, now you might be thinking, okay, X is okay. X is going here and received as a name of X. But what is happening for Y? Y is being received as a name of X. If you are not liking this, you can take a common name, A for suppose alien. To this planet, X, Y, or Z, everyone will be considered as alien. So if I am sending the value of X, it is being received as A. So all the codes will be replaced by A then. X is also okay. Okay, the code with X will also execute, but I am taking something in general. So Y, I am sending Y here, and Y is being received or welcomed as a name of A. A for suppose alien. Suppose you can take any variable name. So the variable names here in our planet, there is no relation with the variable names in their planet. Suppose I am going to different planet, they will consider me as an alien. If I say no, my name is Debabrata, they will not going to listen. For them, I will be alien. If you are going to a different planet, you are going to be named as an alien. Your own name will not be considered there. So same is happening here. I am sending X, Y, and Z, and those all of them are being considered as an alien. So they are receiving those values as A, and they are calculating the answers on the basis of A. That's all. If you want to put some other name, you can put X, you can put anything. But for the timing, let it be A. You can try that in your compiler and let me know if you are facing any issues. So if I run this program, okay, enter first number, the same thing. I can input 5, 7, or anything. I can input 3. So the factorial of 5 is 120, 7 is 5040, 3 is 6. So there is no meaning. If it in our case, it is a small logic. It is just a 5-line code, but in real cases, it might be a 500-line code as well. So there is no meaning to write the same code multiple times. So create a function for that, and you can reuse the function all the time. Whenever it is needed to get the factorial, you can use that. Okay, so that's the thing. Okay, let me take a copy, because in this class it might be required multiple times. So let me write this function somewhere. So this is the function of getting factorial. Okay, I hope this is clear. Okay, otherwise I will check a few more examples. I hope after that it will be clear to you. So the next example, it is saying enter 3 numbers and find if they are prime or not. So I just need to write the prime code. If you are not able to write any code in function, suppose you are thinking I am very weak in function, do not think about that. Just write the function, just write the code in main function and then copy and paste. So suppose I'm interested to know if X is prime or not. Okay, or suppose I am taking one variable A, and I am interested to take if A is prime or not. Okay, or let it be X. If X is prime or not, I'm interested to fetch that. So if you are confident enough on for loop programs, then it will be an easy program for you, because in for loop we have already did that. So suppose I can write f equals to 1, say, or int I equals to 2 to I less than equals to x minus 1. If you can remember our code, how we have determined the prime number, how we crack that logic to find the prime number in our for application classes. So I can simply write this logic. If you are thinking you are not good in function, then you can follow this code. You can simply write the program in main function itself. So I can simply say if f equals to 1, then it is, if it is the older value, I'm not explaining what I'm doing because it is a simple program. We have already done that. X is a prime number. And else I can write X is not a prime number. So this is the code. Now, if you are thinking I'm not good in function, my friends are doing good in function, but I'm not that good. So if this program is working, just do a cut and paste. So I have just cut that code, and here I'm writing similar planet like our main function, public static void. What I can give any name. Let it be like prime this time. And I can put it here. I have just pasted the code, and here I will take input as X. You can take it by any name. In the last program, I have taken it as A. You can put A here as well. For the timing, let me put X. And I can call this function prime with X. I can call this function with Y. I can call this function with Z. Let me do that. So if I compile, yeah, no error. So if I go to the, if I want to run this function, so enter the first number, suppose 7 and 9 and suppose 13. So 7 is a prime number, 9 is not a prime number, and 13 is a prime number. So that is the way to do function. So there is no extra logic needed to crack the function codes. The function, there is no more extra logic for function. You just need to copy and paste your code inside a function. The function header will look like similar like our globe, like our planet, like our function. Public static void main, it looks similar. Instead of main, you have to give a normal name. Here I have given a name like prime. If you are confused like why X will be there, why not Y, why not Z? Because here we have 3 values, and why we are giving the name X here. So do not be confused. You can give any name. Our name and the name at their planet will not be the same. So suppose someone's name is alien here in this planet. So they will be, that person will also be called as alien in their planet. So it happened in that way. X, I am sending the value of X, and that is being received by X, but that is a coincidence. You can take it inside any variable. So I can replace that value with A as well. If I compile, yeah, it's compiled successfully. So just the old logic inside a new function. That's all. So if you are still not able to understand, I will be showing you more examples. Okay. So, but for the time being, let me copy this code because that might be required later, because I will not waste time by writing the same logic, because it is a logic we have already learned. We have already did in our for application classes. So if I go to the slide, it is saying enter 2 numbers and find their power. So it is not like you can send only one value. You can send 2 astronauts as well. Suppose I am saying astronaut because I always think this function as a different planet, and we need to send them because okay, let me show you one thing first before going into this program. Let me show you one thing. Suppose if I do not call this function prime xyz, then this function will never be executed. If I save, if I compile, I have not called prime xyz. Okay, so what will happen? If I go to this part and if I try to run, enter first number, suppose 5, enter second number 7, enter third number 11. So nothing will happen because we are just taking the input, but we are not calling that function. Okay, so you need to call that function, then only it will be executed, because program always start from main function and program ends at main function. So it is being executed line by line, and it starts from main function. So now if you write these three lines, prime xyz, then only it will be executed, it will be called. Okay, so you can also do one thing, you can call some other numbers as well. You can write prime 17. So 17 will also go into this function, into this planet, and will be called as alien. And the same execution will happen for 17 as well. Let me show you. So three values we are giving input, and the last value is a hard-coded value. So 17 will be checked if it is prime or not. So if I go to our function, so that is a just idea that you need to have. You do not need to think about the logic. Okay, so suppose 5, 7 and 11, and the last value 17 was hard coded. We do not need to give any input for that, and it is saying 5 is a prime, 7 is a prime, 11 is a prime, and 17 as well is a prime. Okay, got this idea? So if not, I'm going to show you more examples, don't worry. So probably I have taken the backup. Yeah, I have taken the backup. So what was the question? Enter two number and find their power. So now this time I need to think. Let me start with this function itself. I'm not going to copy and paste, because we are able to see that it is just a simple the same logic we can rewrite inside the function, just because of we can reuse that, nothing else, nothing else. The same type of code we can write. Suppose here I can receive two values, int x and int y, and we can put something like int f equal f, let it be f, or let it be multi product equals to 1. So I can write int I equals to 1. It will iterate y times, if you can remember our code in for application. And what I will do, I forgot, I just need to do p equals to p into x, that's all. So if equal okay, I think this part will not be needed, so I can simply print the answer like system dot out dot println. The power is or the answer is whatever the answer is. I can simply write p, that's all. So now here I can do one thing. I can simply write pow, double w I have used, and I can send x and y. I can send some hard-coded values as well. I can send 5,3. I can send anything. So here I am, okay, not POW, that's why it is showing some error. So it is POW. So I am sending two values here, x and y, and it is being received as x and y here. So you can change the values as well. You can put it A and B, whatever. So in the next example, I am sending 5 and 3. So 5 is being received as x and 3 is being received as y. And I am doing the same, I am implementing the same logic. So if I compile and if I execute the code, why it is not running? Yeah, let me run. Enter the first number. Suppose I can write something 2 to the power 6. I don't know what is the answer. 2 to the power 6 is 64 and 5 to the power 3 is 125. So that's all. You can reuse the code. You do not need to write the same code again and again. You can simply write the same logic. What is you are going to write in the main function. You can write the same logic in your function. It is your ready-made, it is your customized function. So the same logic you can write here and your function will be ready. That's all. There is nothing else. If you are scared of, write the same logic in main function and then copy and paste. The same thing, nothing new. Okay. So if I go to the next slide, so I hope this is clear. If not, just let me know in the comment section, or you can send me the mail, or if we are doing the offline classes, you can tell me at that at that class as well. Okay, so if I go to topic 2, so we need to know what is return type function. So what is return type function? Suppose anyone is asking about this thing, enter three numbers and find their sum of factorials. So we have already faced the factorials. But now if someone is asking for sum of their factorials, how to face that? We have already done that program. Suppose, let me take 3 inputs quickly. Enter third number and it will be Z, suppose. Enter third number. We have just done that program, and it will be, I have copied it somewhere, the factorial program, yeah, the small one, public static void Guha. So I can copy this program. Okay, let me copy this here and let me take a backup of the power function. If it is needed, I can use that later. So here it is. So I have written a function called Guha that is able to find the factorial of few numbers. So I can write something Guha x. It will calculate the factorial of the value x. Then Guha y, it will calculate the factorial of y, and Guha z, 3 numbers, and it will calculate the factorial of those 3 numbers. So now if I run this function just to check if it is working fine or not, because we have just completed this program few minutes back. Yeah, it is working. So now if it is asking for the sum, how can I get the sum? Because first 5 is going into this planet or going into this function, and it is calculating the factorial of 5. After that, y is being sent separately, means y means 7. I have entered 7 is being sent separately, and it is calculating the factorial of 7 in this planet. After that, I am sending z, and in this planet it is calculating the factorial of z. So how can I get the sum of them? Because I am sending those values into some different planet, and calculation is being done in that function or in that planet itself. So how can I get them back? So here I need to follow one simple thing. We just need to, rather printing the answer, I will return the answer. The answer is being stored in F. So I'm not going to print that. I am returning it. So while returning, it is saying unexpected return value. So you have to declare like, okay, I will send that astronaut into your planet and I will get it back again. I will return integer. F is integer. You can see int f equals to 1. So f is integer. So I am declaring I will be returning that value. I will be returning one integer value. If you write void here, that means you are not going to return anything. But here I am saying int. That means we are going to return something. Okay, so be prepared for that. And if you are returning some value, then you need to receive that here. So I can receive that in some variable called p. I can receive this in some variable q. I can receive this in some variable r. Okay, so pqr, I can receive those 3 values. In the previous program, I do not need to give something like this because I'm not going to receive anything. But in this program, I'm going to receive something. So that's why I need to put this thing. Any doubt, just let me know in the comment box, obviously. So any doubt. So here, what I'm doing, I am sending what is the difference from the last program. Last program, it was void. I am writing now int because I am returning one integer value. If it is double, then you need to write double here. But here in this case, we are returning an integer value. So we have to write something like this. Okay, and here we need to receive this. Okay, once received the values in our earth, in our globe, I can simply print them. Now all the values in our hand, and I can simply print like the sum of factorial is p plus q plus r. That's all. So if I run, let me go to let me call the main function. Enter first number, suppose 5, 7, and suppose 4. So the answer will be 5184, something like that. I really do not know. I'm not that good in mathematics, so you can see that. Okay. So if you want to combine all the results from a different function call, so the only way is you have to return them back. If they are independent, suppose you do not care, you just need the factorial of different values, then it is okay. But if you are looking for the sum of them, or if you want to combine the result, or if you want to combine the answers, then the only choice is you have to return those values here and return. So if it is not clear, I'll be showing you more example. So let me give some more example. Let me take a backup of this factorial. Okay. It was a void and it was the integer. The same thing you can see void here, it is int. Here we are printing the answer and here we are returning the answer. That's all, nothing else. So now what else is there in our slide? Enter three numbers and find if all of them are prime or not. Okay, all of them are prime or not. So I will enter three values and I need to check if all of them are prime or not. So here I can copy this program. There is no meaning to write it once again. So what I can do, I can write something int prime, something like that. Because I'm going to return something, I do not need to write this if else block. Here, what I will do, I will simply return f. Simply return f because f is integer, you can see, and that's why I have mentioned int here. Okay, so if I receive 1, that means it is prime. If I receive 0, it means it is non-prime. Okay, so what I'm going to do, here the function name is prime. So I'm going to receive those value inside PQR. So it is not PQR, you can use any value, okay, any variable. So let me write that. Prime X, prime Y, prime Z, you can receive it inside A, B, C itself. Any value you can use, okay. So I can simply write if A equals to 1, and then B equals to 1, and then C equals to 1, then I can say all are prime. And else I can write all are not prime. At least some values are there which is not prime. So it is again combining all the result. It is not like I am calculating if X is prime or not, if Y is prime or not. If it is asking for, I am giving three numbers and you need to find if the individual numbers are prime or not. If it is, the question is in like that way, then void is enough. But in this question, it is asking check and confirm if all the numbers are prime or not. So we need to compare the results for from each execution. And that's why we need to return the answers so that I can compare all the answers here. If all of them are 1, then I can say all numbers are prime. Okay. So all are prime. So if I compile and if I run, suppose I am giving 5, 7, and 11. So it will return all our prime numbers. So if I say, if I give 5, 9, and 11, so 9 is not prime number. So it should show something like all are not prime number. Yeah, it is showing all are not a prime number. Okay. So something like that. So if I go to the program, so this is the prime program. Okay. So you can take a backup of that as well. Okay. And I can do one thing. You can think why I'm writing int. So if needed, you can give some other variables as well. Suppose because we are not doing anything new. We are not doing any new logic. It is an easy chapter. So let me make some changes and make it, let me show you something new. So instead of int, you can also choose Boolean. So what is Boolean now? Instead of 1 and 0, you can use Boolean true and false. 1, instead of 1, you can use true. Instead of 0, you can use false. That's all. That's all you can use. So here, if it is Boolean, you need to write Boolean. That's all. So whatever you are returning, you need to put the data type, put the similar data type. Okay. So it is nothing tough. Instead of 1, I have written true. Instead of 0, you have written false. So here, obviously, these things will not be anymore in integer, it will be Boolean. And here you can write, instead of 1, you can write true. The same thing, instead of 1 and 0, it is true and false. So in general, in Java, whatever functions we have written, like which is asking yes or no, like if the number is prime, yes or no, if the number is palindrome, yes or no, if the number is Armstrong, yes or no. So all those functions are returning true and false. You can simply create them as returning integer as well, 1 and 0. But why integer? It is just returning 1 and 0. So instead of 1 and 0, I can return true and false. So you can see I am writing A equals to true, B equals to true, C equals to true. The same thing. So if I run, if I compile and if I run again, suppose let me give 5, 7 and 11. So all of them will be returning true and I can see all are prime number. So if I make some changes in this program, I can also directly copy this here. There is no need to store them, to behave like a child, to store them inside A and then compare A. There is no meaning. So I can directly compile, I can directly compare prime X as well. So there is no need to store them inside B and then checking B. There is no need. You can directly check them as well. In the last program as well, we can directly print the sum of factorial is Guha X plus Guha Y plus Guha Z directly. You do not need to store them somewhere and then need to compare. It is a childish thing. So we can simply, without storing it somewhere and then checking that variable if it is true or not, we can simply directly check that value. Okay. So prime X will return true or false, and I'm checking if it is true or not. Okay. So if I compile, because I'm not doing anything new with the logic, so that's why I thought to show you Boolean numbers here, Boolean variables. So again, if I'm writing 5, 7, and 9, suppose, so it will be saying all are not a prime number. Because in the last checking, it is saying it is returning false. So false equals to true? No. False is not equals to true. So it is going for the else statement and it is showing all are not a prime number. Got it? All are not prime, I think. That will make some sense. Okay. You can do one more update as well. You can simply delete this true. You can simply delete this true. Now what I'm doing, just think logically. It is returning true. It is returning true if I enter 5, 7, and 9, and it is getting false here. So true, true, and false. So it is not true. So it will go into the else block. If all the values are true, if all the conditions are true, then this line will be executed. So that is the beauty of using Boolean variable. You do not need to store anything. You do not need to compare. Directly, the value will come like this, and you can compare like true or false. You do not need to do anything extra. You do not need to check. So people sometimes write this function in this manner. They rename it like is prime, like a normal English question, like do you live in Kolkata? Suppose, do you live in New Delhi? Do you live in London? Something like that. So your answer will be always yes or no. Or here in this case, it will be always true or false. So whenever you can see a function is starting with is, that means it will be returning Boolean. So I am trying to go with the standards. So obviously we will learn this later as well. What are the other ready-made functions available in Java? But all the ready-made functions available in Java, if it is starting with is, that means it is returning Boolean. That means it is returning true or false if it is starting with is. So I am trying to build our function in that manner. You can, anyhow, it is not mandatory you have to give is at the starting. But if it is starting from is, it looks good. You can see it is saying is prime X, is prime Y. It looks like a standard programming. And yeah, another advantage, when I did this for the first time, when I wrote this if else statement, my friends were like, oh wow, you are doing programming in a smart way, but it is same. Either you are returning 1 and 0, or you are returning true or false, or you are directly using this function. All of them are same. The purpose is to find all of them are prime or not. The purpose is same. You will not get any extra marks for this, or you will not get any extra salary for writing this thing. But still, it is good to write this kind of programming, because in the initial days I was really scared of when my friend is doing this kind of program and I am still writing 1 and 0. I am still comparing the values with equals to 1 and 0. I was thinking like, wow, how he or she is doing the program in this way. So it is very simple. If you are returning true and false, you do not need to compare. The value itself will represent the true or false. If it is true, suppose I am giving 5, 7, and 9. So this part will be considered as a true. This part will be considered as a true, but this condition will fail. It will be returning false. So the control will go into the else block. That's all. Got it? So if I run this for the final time, for the last time, if I run this, because I have done some modification. So if I run 5, 7, and 9, it will say all are not prime. If I enter something like 5, 7, 11, so it should say like, okay, all of them are prime. Let me show you. Yeah, all are prime. So any issues, anything still you are not able to understand, just let me know. Yeah, so that was the example I forgot to show. So now the last one, pow function. So what is pow function? If I show you the pow function, where is I have taken one backup of pow. So our pow function will behave same like math.pow. Okay, now why math.pow is there? I will explain that later, but for the time being, let me copy this. Okay, first let me do one thing. Let me copy this is prime function. It is quite good. Let me replace that. Let me replace the previous one with this smart approach. It is small and smart. So now let me copy public static void pow. If I paste it here, and if I want to find the pow of two numbers and I need some value in return, so it behaves like the normal math.pow function. Let me show you how normal math.pow function works. Normal math.pow function works in this way. Math.pow, suppose x comma y. And our function should also work in that way. So we will explore more later. So we will explore how this math.pow is working. So we are trying to go closer as per the standard. Okay, so they are using math.pow. Obviously, it is a function, and someone from the Java team has written this code inside this pow function. So it is similar like our pow function. Our pow function having double W to just differentiate with the names actually. Otherwise, it will be similar name. So I am using double W here, and I want to do the similar thing in our case. So what I will do, instead of void, I will be returning something, suppose int, and I will be returning return p. So in their function as well, they are going to do something like this. Someone has written that code inside math.pow function, and it is hidden so that I cannot see the code inside of this pow. In later classes, I will also hide the code of pow as well, so that no one can see this function. Okay, I will create that function and I will hide it somewhere, and it will behave same like math.pow. And why math is coming, I will explain that as well later. Okay, so for the time being, I am trying to put the similarity as much as I can. So both the things, x and y, is being taken input from the user, and both of these functions are returning the answer. So if I compile and if I run, suppose if I enter 5 and 3, it should return 125. So look, 125. Here it is returning in double, and we are returning in integer. So I will explain everything. Why it is in double? Because they are okay. I can also return it in double. Okay, so let me write that. Let me take the variable in double, and if I return it, return p, and here I can just simply write double pow, and I can return the value in double. So let me run this main function once again. And suppose I am giving 5 and 3 and both the values are 125. So I am trying to go as close as the ready-made one. So this is created by Java developers itself, and this is created by us. So in the later classes, I will show the meaning of math dot. I will hide that code and it will be more realistic. So whatever we will create, that can be used like their math function, their math power function. I will use our power function later. Okay. So, but idea is clear. Someone has written the code inside pow and that code is being hidden. Okay. That's why we are not able to see that code, but we can use that pow function as needed. Okay. We are also using our pow functions here. Okay. So whatever are the logics we need to put here inside, we need to put all the logic inside and we need to calculate that value and return that answer, return that value, and our code will be hidden. So that is the purpose at the end. Okay. So that's the thing. Okay. So we have another two parts, but I think for the function, I think until this part, it is okay. I will suggest you to revise all the programs I have done to solve the chapter. There is one chapter called the chapter name is function in the chapter in the album front end exercise. All the details will be provided in the detail section of this class. So there is something called coding exercise basic. I guess I forgot the name of this album. Coding exercise basic. You can go to that chapter and you can solve this question. Okay. Coding exercise basic and the chapter name is function. You can check this exercise and yeah, we can see further examples of function. So today we have just learned how to reuse a function, and in the next class of function I will show you why this another, how can I get the advantage of this another part, like another advantage like modularity. So how can I use the advantages of function in terms of modularity. So today we have seen how we can get the advantage of reusability. If we use function, we do not need to write the code multiple times. We can reuse the code. And next day I will show you how we can do that. How can we take the advantage of modularity? Okay. So for the time being, solve the exercise, then you will be more clear with the idea and I will show you further examples of function. So that's all for the day. Bye. Practice all the programs or functions and I hope it will be clear. Okay, if the code is needed, just mention that in the comment section. I will share the codes as well. Okay, but I prefer to type all the codes by yourself. If you face any error, just take the screenshot and paste it in the comment section. I will take a look and I will be able to help you. What is the error? Why the error you are getting the error? I can explain. Okay, so that's all for the day. Bye. See you again with another class of function. Bye.